be talking about the muscular system. So I'm going to share screen with you. Make sure you have coffee or tea or your favorite green beverage, whatever color beverage you prefer, and sit tight. Or maybe instead of sitting tight, get a pen and paper out. Okay, share screen. So the muscular system. Why do we have muscles? We talked about the skeletal system previously and why we have bones. So this time, why do we have muscles? The most obvious answer would be for movement, for producing movement, so for locomotion. Another obvious answer would be to maintain posture against gravity. So if you didn't have muscles, then you would just fall down to the floor. Stabilizing joints. This is very important and very important for yogis. Very important as well with people who have hypermobility, which means you're more flexible or your range of motion in your joints is greater than most of the population. And this is really most yogis, or at least most people who join a yoga teacher training program. Because most people who join a yoga teacher training program, you are already excelling in the day-to-day, everyday class. So you're already more flexible naturally. And there's factors affecting flexibility that we discussed in the previous lecture. Which is very good for yoga, very good for getting into the poses very easily. But what you might find is sometimes the joints are not stable. So sometimes you can have sprains, you can easily get sprains, strains. There are some people who have joints that easily get dislocated as well, so that could be a problem. More commonly, you might have problems with this hyperlaxity in the hip joint, in the shoulder joint, and in the knee joint. So if you have problems there, some feeling of loosening, instability, sometimes maybe even pain after the day after a yoga class or right after the yoga class, sometimes just right after doing certain poses, your joints might not be very stable. So be careful about that and think about using muscles to stabilize the joints. So we'll talk about that more and more as we go on. Generating heat. Notice that when it's maybe winter time or it's very cold, you start shivering. So when you start shivering, it's actually your muscles making an involuntary action to try to warm itself, to try to create heat, So the muscles are involuntarily contracting. It's your body and mind's response to the body temperature that is starting to go down. So your system is trying to make a way to stabilize the temperature by shivering, okay, by contracting the muscles. And by contracting the muscles, you generate heat. Movement of substances is number 5. So this one is not as obvious, but when you think about it, all of your digestive system, from the moment you swallow the food, as the food passes through the gastrointestinal tract, the GI tract, all the way to the intestines, and then out through the anus, you have smooth muscles there that is moving the substances or the food from the time of swallowing and then through all of that system, through all of the GI tract. So that's an example of movement of substances. Regulation of organ volumes as well. So for example, the lungs. Okay, so the lungs are actually passive. You can think of it as like a sack, and the lungs, unlike the heart, is not a muscle. Um, the muscle here that is moving is the diaphragm. And so the contraction and relaxation of the diaphragm is causing a change in the volume of the lungs. So when the diaphragm is pulling the lungs, it creates more space, and that's when the inhalation happens. And then the opposite, when the diaphragm relaxes, it pushes up. It has this sort of shape, okay? So when it goes down like this, it creates more space in the lungs. When it goes up like this, it creates less space in the lungs. When there's less space, that's when the exhalation happens. So regulation of organ volumes would be the last function of the muscles. Your muscle tissue has 3 types. So we'll look at 3 types of muscle tissue. The first one is skeletal muscle. And the skeletal muscle really is the type of muscle that we think of when we do exercise or yoga or any action or movement. These are striated, which means they have this shape. Okay, you'll have a diagram later, but it's more like straight lines. They're voluntary, which means you can think about moving a muscle and it will move. So for example, I can think about lifting my arm and I can do that. So with my own volition. But for example, I cannot ask my heart or just think, okay, heart, you have to stop or move this way or move that way. So that's a different muscle. Or for example, the diaphragm as well. Those are involuntary. So what else about the skeletal muscle? It functions to move the skeleton. So that's why we said that when we think about yoga movements, it's really skeletal muscles that we are talking about. If you remember, muscles and bone work together to create a movement. So remember that example. So you have bone here. I'm just doing this very, very simply, right? And then let's take the bicep muscle. It crosses over, starts from here, and then inserts tendons insert into the radius ulna. When this muscle contracts, then it pulls onto the bone, and it creates a movement. So there's a movement. Okay, so that's happening in all of the joints in the body. The muscle is going over the joint. Okay, and that's how you can think of it as like you can think of your body like a machine, and it's a machine of bones and muscles. As the muscles contract, it moves different parts of that machine or different bones in the body. Your skeletal muscles also helps in maintaining posture. Okay, most notably, for example, your transversus abdominis, which is a very big and deep muscle. Deep meaning it's not superficial or outside. You can't see it by looking because it's covered or it's layered by other muscles. So it's like the deepest layer closest to the axis of the body. So the transversus abdominis runs from the spine, and it goes around like a girdle. Okay, it goes around like a girdle across the lower abdomen. Let me show you. Here. All right. So when you have good core muscles, generally what we're talking about is the transversus abdominis, and this is really what helps maintain your posture. When the transversus abdominis is weak, oftentimes you see posture like this. Okay, and sometimes the belly sticking out, the lumbar spine caving in, and then it starts to pull on the back, pulling on the muscles here, and sometimes you get back pain as well. So by keeping the transversus abdominis strong, core exercises, then it helps you have good posture. Okay. Sometimes you can have a very flexible student, very flexible person, and you can see that they don't have much shape in their muscles or muscle tone, and you can see that they're also not very good with their posture. And then you can see someone who is maybe not very flexible, but let's say they go to the gym or they do some other sport that trains their muscles, core muscles, and the back muscles also to get stronger. And you can see that they have good posture. Okay. So last thing is generating heat. So we've already talked about that. The example was when we shiver. Next type of skeletal, this next type of muscle is the cardiac muscle. So cardiac means the heart. And this is striated, so it's got the same shape as the skeletal muscle. However, it's involuntary. So it's not under your conscious control. You don't have to think, or you don't have to think about it. The muscle just moves on its own. It has its own system. It has its own sensors. It goes through a different pathway in the brain. Okay. It functions in pumping blood around the body. What's interesting here is that even though it's an involuntary muscle, you can still have a degree of control of your heart rate, for example. How do we do that? Well, as yogis, we practice pranayama, for example. And when we practice certain types of pranayama, like the slow, deep breaths, the alternate nostril breathing, which is anuloma viloma pranayama, also called nadi shodhana, and also deeper exhales, longer than the inhales. You can bring about this overall relaxation in the body, and also practice to lower the heart rate. Okay, which is why we always recommend, which is why yoga postures always goes hand in hand with the breathing. You can have two yogis and one yogi doing the postures really, really well, but not really incorporating the breathing techniques, and the effect on the whole energy system and the whole physical system is not the same as a yogi who maybe doesn't have the same range of motion or flexibility in their joints, but is breathing deeply and is breathing slowly. Okay, so you can imagine that the yogi who is breathing deeply and breathing more slowly, this yogi is bringing about more relaxation into the whole body and into the whole energy system. You can do a short test. You can do this short experiment right now. So take your second and third fingers and look for your pulse. After I show you how to do this, you might want to pause the video for a little while so that you can have more time to do it. But anyway, I'll walk you through it. So look for your pulse, and then take a deep inhale through the nose. We always breathe through the nose in yoga. And deep exhale. Okay, so I'd like you to find out what is happening to the heart rate. Where is it faster and where it is slower? You can pause this right now and find out. So the answer would be, if you're doing it correctly. If not, maybe give yourself some time. During the exhale, the heart rate actually goes slower, right? So during the inhale it's boom, 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 and exhale do 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 do. It goes slower on the exhale. More on that when we talk about the respiratory system. But with longer exhales during the yoga practice, then you can bring about more relaxation into the physical body and the energy system. The heart rate is able to go down. This has already been proven scientifically. There are several studies on hypertension. So hypertension is condition where the blood pressure is elevated constantly, and hypertension is one of the markers for heart disease later on. So it's something that is best controlled right away. So in one of these experiments, they had, or research experiments, they had one group of people do Shavasana. And you all know what Shavasana is. You've experienced it. You've experienced a deep relaxation in Shavasana. And then another group of people just relaxing and sitting down on the couch. And after 3 months of practice, daily practice, they saw that the group that were doing Shavasana, the systolic and diastolic numbers went down, and in the Shavasana group nothing happened. So in the couch sitting group nothing happened. So with the Shavasana practice, the hypertension was able to go away. Okay, so smooth visceral muscles. This is the third one. It is non-striated and it's involuntary. So we talked about the gastrointestinal tract, your digestive system. So these are the types of muscle. For example, when you swallow, there's sensors in your esophagus that detects that there's something there, and then muscles start to move the food down. And then we also spoke about the diaphragm and how the diaphragm regulates the volume of the lungs. And the volume of the lungs is what creates this inhalation and exhalation. How skeletal muscles produce movement. So let's go through it again. It's really important. A muscle is attached to 2 articulating bones. So in other words, you've got 2 bones. The space between the bone is the articulation or the joint, right? So 2 articulating bones just means two bones that are separate but close to each other. Okay, and the space between them, that's called the joint. So number 2, the point where the muscle inserts in the stationary bone is called the origin. So stationary means it's the non-moving bone. So if we take that example of the radius ulna and your humerus bone and then the bicep muscle. So the stationary bone in this case is the humerus. The point where it inserts in the moving bone, so here, okay, is the insertion. So you have origin and insertion. when the muscle contracts, it shortens. So the contraction creates a shortening of the muscles, and usually move the moving bone towards the stationary bone. Okay. Muscles work in pairs. There's a prime mover, or also called the agonist. It causes the movement, and the antagonist, which is the antagonist opposes the movement by relaxing and lengthening. Okay, so this is a really important concept for yoga teachers. Okay, so muscles work in pairs. The first one is the one that does the action or causes the movement, and then the opposite muscle relaxes and lengthens. So what does that mean? So it means that if I want to lengthen, and which is stretching, right? If I want to, which is what we do in yoga, if I want to stretch a muscle, then I can use the opposite muscle to help. So by contracting, actively contracting, then you can create more of a lengthening and more of a release, which is what we do in the dynamic forms of yoga, Hatha Yoga, Ashtanga Yoga, for example. So if I want to, and which is also why, unlike ballet, every time we stretch the back of the leg, we're always flexing our feet in yoga, if you notice that. If you come from a dance ballet background, the toes are always pointed in ballet. That's really for aesthetics, because you want the lines to be long. In yoga, you're trying to create, it's more of the stretch that you're looking for. So here's your leg. So when you contract your quadricep muscle, then the hamstrings lengthen. Okay, so the hamstrings lengthen. Muscles work in pairs. You don't see this concept in action, for example, when you do a restorative yoga or a yin yoga class. In a true yin yoga class, you're not supposed to create muscle tension. So this concept is not used there, for example. Really interesting. Okay, last one. Prime movers are supported by synergists and fixators. So this is another important concept. So it's not just one muscle creating the action. You have helper muscles, synergist muscles. So muscles that are helping out to do the work. So for example, when you're doing a bakasana, crow pose, or a headstand, you can't just say, okay, use this muscle, contract this one muscle, because it's many muscles working together. Even when you are just trying to stretch your arms up and get some length through your spine, there's many muscles supporting each other. You get more of a picture of this as we have a look at the muscles a little later on, the individual muscles a little later on. So there's many different muscles helping each other. Now, here's another important note. We're going to delve a little bit into biomechanics now. Okay, so every person has a few dominant muscles. So think of them as favorite muscles. You have muscles that are more developed. You have muscles that you prefer to use. It's not a conscious thing, like I prefer to use my biceps, or I prefer. It's just a body intelligence thing. It's what you're naturally predisposed to. Just like you have a dominant side, like some people are right-handed, some people are left-handed, so you have a dominant side. And you can maybe sometimes notice when you do yoga, you have one side that is more flexible than the other, especially when you're starting out. That is a very common thing. As you progress in your practice, you notice that differentiation or discrepancy becomes smaller and smaller, and you become more balanced. So that's in flexibility. In use of muscles and muscle strength, you also have certain dominant muscles, and it's different for everyone. You can consult. How do you know which are your dominant muscles? You can take a few tests, exercise tests. When we talk about biomechanics, or if you take a peek at the biomechanics slides, you can see the tests there. But it will give you some idea as well, which muscles are more dominant and which muscles are weaker in your system. It would be actually best if you consult a physiotherapist, because physiotherapists are more trained to do that. So they can see straight away by doing a series of tests which muscles are more dominant in your body, which muscles you prefer to use. Okay, so why is that important? It's important to be aware of these dominant muscles and really start to think about using more of the synergist muscles. Sometimes you hear the term recruit more muscles, okay? So you want to recruit more muscles, different muscles, because what happens is if you just keep using the dominant muscle, then it will get more and more dominant, stronger and stronger. And the weaker muscles, because they're not being used or utilized, they just get weaker and weaker. So it creates, it compounds this imbalance in the body. It creates more of an imbalance. And then the longer you do, it's like a bad habit, right? So it's like a bad habit. And then the longer you do that, the more, the greater the imbalance becomes in the body. So you want to start thinking about that now, start to be aware of how your body moves, and check out the slides on biomechanics, and talk to your favorite physiotherapist as well, and discuss that matter. People who are also very good with fitness instruction, notably maybe bodybuilding, can also maybe help you with that. Okay, so characteristics of muscle tissue. We've got 4. Muscle tissue is excitable, which means that with electrical stimulation, they react. There's a reaction. Skeletal muscles are contractile, which means, okay, it comes from the first one. So they're excitable. So there's a stimulation and they react to this electrical stimulation. What is the reaction? They contract, right? So remember that example? Let's do another example, right? The brain is asking the back muscles to contract, and it creates a back bend, okay? There's a contraction that happens in the muscles of the back. Muscles are extensible. So in anatomical terms, what this means is it can stretch. And number 4, it's elastic. So in this context, elastic doesn't mean stretchable. It means, elastic means it can go back to its shape. Okay, so the muscle reacts to stimulus by contracting. It can also stretch, and it can go back to its shape. So here, take a photo of this in your mind and sort of like memorize it. This is what the this is the structure of the skeletal muscle. We start off with this very small element here, which is the myofibril. Think of it as a fiber. Think of it as spaghetti, okay? And this is, it's not the smallest, but so let's think of this as the main element. And then you have loads of this. You have a lot of this myofibril. And think about this myofibril now, okay, as fibers, muscle fibers. And you take a lot of the myofibril and you take a bundle of it, okay, as you can see here, it's a bundle. And let's say you wrap it, okay, think of like Glad wrap, cling wrap, plastic wrap. So you wrap it around. You wrap it so that you create one bundle. Okay, so let's call this one bundle the sarcolemma. Okay, so you no, sorry, the actual wrapping is called the sarcolemma. Okay, so you've got one bundle here. So let's get more bundles together, all wrapped by sarcolemma, and let's bundle them up. So we bundle them up, and we're gonna call that wrapping something else. We'll call it the endomysium. Okay, and then you get more of these bundles, and you bundle them up. So here we are now, and we'll call this wrapping now the perimysium, and get a bundle of that, and then the wrapping will be called the epimysium. So the epimysium, perimysium, endomysium, and the sarcolemma, they are the connective tissue. Okay, connective tissue is connecting, does what it says on the tin. It connects muscle fibers. Okay, so this end bit now, this part here, okay, this is the deep fascia, but all of this is actually fascia, sorry. All of the epimysium, perimysium, all of the coverings, the glad wrap, all of that is fascia. Okay, so when we get here, this part here attaches to a bone. So muscle attaching to bone, that is a tendon. If it's something that attaches bone to bone, it's a ligament. It's stronger. This one is also very strong, but not as strong as a ligament. Okay, so here you have tendon. So what happens? We said that the muscle is excitable. It reacts to an electrical stimulus, and the reaction is a contraction, right? So contraction happens. So that contraction happens, and that electrical stimulus happens here in the myofibril. Let me see if I can find, okay. It happens here. You can see this small square, and you take that and enlarge it, you will see this. All right, so look at this Z disc here and this Z disc there. When the contraction happens, just basically the space between the Z discs gets smaller. It comes closer. Contraction. Okay. So the contraction happens, the electrical stimulus happens in this myofibril. Contraction happens, this pulls on the sarcolemma, right? Because they're all attached. It pulls on the endomysium, pulls on the perimysium, pulls on the epimysium, then pulls on the tendon. And what is the tendon attached to? Bone. So then it pulls on the bone. So that's how locomotion happens or movement happens. Okay. Let's talk about types of muscle contraction. So first of all, muscle tone. You've probably heard heard it talked about, if that person has good muscle tone. So muscle tone is actually a partial contraction of the muscle. It's constant muscle contraction. So when you've worked a muscle enough, you already create a partial contraction, which actually requires energy. So people who have a lot of muscle tone, at rest, they are actually burning more calories than somebody who has less muscle tone. So it's a good tip, which is not just coming out of the air, but it's a good scientific tip for somebody who is looking to increase their metabolism and lose weight, is to not be afraid to put on some muscle tone. So the muscle tone gives muscles their firmness, and the tension is necessary for maintaining posture. So all of us, because we have, all of us have muscle tone. Some of us have more defined muscle tone than others, depending on the work and training that we've done. There's two types of muscle contraction that we will talk about here. First, let's talk about isotonic contractions. So in isotonic contractions, the muscles contract and shorten, creating a movement. Load force is less than muscle force. So muscles contract and shorten to create a movement. So that's easy, right? So if I want to, my leg is here. I should have worn something else so you can see better. Maybe here. Okay, it's good. Yeah, my leg is here. I contract this muscle, quadricep, and it creates movement. Okay, good. Load force is less than muscle force. So your think of load force. Think of your muscle force as the strength of your muscle. Okay, so let's say I'm going to pick something up. I'm going to pick this up. Okay. Okay, I'm gonna pick it up from the ground, from here. Not from the ground, but from below. Okay, this object has load force. So think of it like the heaviness of this object. If the heaviness of the object, or the load force, is less, so it's lighter, less than the muscle force, then movement occurs. Okay, so I can do this because the load force is less, the muscle force is greater. Good. So remember that as we move along. Let's talk about the two types of isotonic contraction. You have concentric contraction, which is towards the center and involves shortening of the muscle. Okay, so here is the bicep muscle shortening, and eccentric contraction is you're not just dropping and relaxing, but it's in the process of the muscle is moving away from the center. It's in the process of lengthening, but it's not just a letting go. There's like resistance involved. Okay, so that's eccentric contraction. Isometric contraction, muscles contract, but there's no shortening of the muscle and no movement is generated. Load force is more than the muscle force. So you can think of this as when we hold the poses in yoga. We're contracting the muscles, but there's no movement being generated. So like, for example, in plank pose, most of the poses in yoga, when you get to the end, okay, there's no more, you're not generating the movement you're not generating any more movement. You're just holding the pose. Or you can think of it this way: load force is more than muscle force. So in that example that we had, I have my object, which has some load force. and I have my bicep muscle, which has some muscle force. And let's say this object is really heavy and I try to lift it and nothing happens. So nothing happens because the load force is greater than or equal to. The great thing about doing this online and recorded like this is that you can always go back and study it again and again if there are certain concepts that that is not easy to understand. Okay. This is just another look at the contraction of the muscle. If you look here, I hope you see where my cursor is, where my arrow is. So you can see here these bands, dark and light bands. And when the muscle reacts to electrical stimulus, this actually shortens. So as we said before, look at the Z disc here and the Z disc there, and the contraction is actually a shortening that happens there. This is the area of one Z disc to another Z disc is called the sarcomere. Here is a microscopic view of that, and here is a diagram view of that. Okay, we're not going to go too deeply into that. We're going to leave it for now. We're going to move into muscle metabolism. Okay, so muscles need energy. Okay, muscles need, but please don't starve yourself. Muscles need energy in order for it to just be maintained and also to move, okay, to do its function, all of the functions that we've mentioned. Muscles need energy in the form, okay, of ATP, adenosine triphosphate. So when you eat food, when you eat an apple, there's many components of that apple or whatever it is that you eat through your digestive system. The process of digestion is that you take in the different substances, the different foods, and you turn it into something that can be used by, in this case, the muscles. So the form of energy or the food that your muscles need is ATP, adenosine triphosphate. So adenosine triphosphate or ATP can be obtained in 4 ways, at least 4 ways. Okay, so the first one is the phosphation system. So you actually have ATP in your body already. ATP is occurring in the body, and what happens is if you're not using this ATP, so you're not creating an action, it needs to be stored somewhere. So the system, the body donates a phosphate group to creatine. So creatine is in your body as a substance that's naturally occurring in your body. So the phosphate group is donated to the creatine, which creates creatine phosphate and adenosine diphosphate. So it goes from triphosphate to diphosphate. So think of it as the inactive phase or the storage phase. So now let's say we need movement. So let's say we need to use our muscles. We need to jump up really high. So what happens is creatine phosphate through a process that includes creatine kinase, donates this phosphate group back to the ADP. So the ADP you add you add the phosphate group. In other words, the creatine phosphate donates back the phosphate into the ADP. So then you have ATP, and then creatine is again released. With this system, the phosphagen system, you're only creating one ATP, which is not a lot. So it's usually for explosive actions, and it's not something that your body can rely upon to do a long period of work. So your body needs other systems, other ways to create ATP, more ATP for longer if you're wanting to do something that is not just one explosive action. So let's say I don't want to jump up just once, but I want to keep jumping up and down for a few minutes. Okay, so your body cannot just rely on the phosphagen system, on the ATP and the creatine, etc. So your body has to look for other ways to create this ATP. So the body is taking now blood glucose and muscle glycogen. So in the process of glycogenolysis, you take one glucose molecule, which is sugar, right? So your body needs sugar. Don't think all sugars are bad. Your body needs sugar. So one glucose molecule, and through this process you will get 2 pyruvate molecules and 2 ATP. Okay, so now you're creating more ATP. In the phosphagen system you created 1. In this system you're creating 2, and you're also creating 2 pyruvate. What's happening to the pyruvate? Okay, 2 things can happen. I can either not incorporate oxygen because there's an oxygen depletion in the body. And what happens is lactic acid goes into the blood, and then your muscles go into fatigue. If you've ever done something, an action, let's say you've been running, and then it's just suddenly like, oh, I can't do anymore. Or in the middle of yoga practice, a very dynamic yoga practice, and you just go, oh, it's shavasana, I can't do anymore. You don't collapse, but you're or let's say you're holding a pose, and it's just requiring a lot of strength, and then just suddenly you have to let go of the pose. So you can think of it that way, lactic acid into the blood. So the muscles get tired and just, okay, that's it. I've hit a wall, can't work anymore. Otherwise, and this is again another reason why breathing and pranayama is so important in yoga. We've already discussed how the deep long breaths especially with the exhales longer than the inhale, creates more relaxation in the body. Now you will find out how deep long breaths can create more energy in the body, more ATP. So pyruvate with oxygen, which is what you're giving to the body when you breathe, right? This then creates aerobic respiration, which is another way that your body can generate ATP. Now, more oxygen in the body. When you breathe deeper, you are actually breathing more. When you breathe deeper and slower, so not just deeper but also slower, when you breathe deeper and more slowly, you're allowing more time for the exchange of gases to happen in the lungs. So you are getting more oxygen than just naturally breathing. Okay, so really important in yoga, but also probably really important in just your day-to-day life to really make the most of bringing more oxygen into the body by breathing more slowly and deeply. Which is why I don't really, what breaks my heart when I see like these lovely flows on Instagram and on YouTube, and you can just tell by looking that they're, because of the speed of the flows that they're doing, that they're not really taking deep, long breaths. Because when you do a flow, you're supposed, or a vinyasa, you're supposed to do one breath per movement. But if the movement is that, you know, then that's not a deep, long breath. So slow, go slow with your flow, please, for the sake of your oxygen levels and your ATP. Okay, so okay, aerobic cellular respiration. Oxygen is now included in this process. So you take pyruvic acid, right? Here, pyruvic acid, but also fatty acids and amino acids. Amino acids are proteins. And through a process to these two, and with the two processes of the Krebs cycle and electron transport chain, you can look that up later. It's out of the scope of our lecture today. But Krebs cycle and electron transport chain, and then with the oxygen, this now creates 36 ATP. So a lot more than just 1 or 2, but 36 ATP, and what else? H2O and CO2. Okay, cool. We're going to pause here and continue later on with part 2 of this program. So I'll see you in a bit.